The first skill we're going to talk about is how to simplify radicals. As we talked about in class, there are two ways to do it. I can either look for perfect squares, or I can do factor trees. This video I'm going to talk about doing factor trees, but if you're really good at spotting multiples of perfect, then you can do that. So you want to ask if something is a perfect square? Yes. So I can just do the square root of 100 is 10. But if you see why that works, then I can do a factor tree to show you why. So to do a factor tree, you start with anything that you know that multiplies to the number. So anything that multiplies to 100, which I'm going to think of as 10 times 10. If I can keep breaking down each of these branches, then I will. That's why we call it a tree, because you get all these branches. So 10 is 2 times 5, and then I have another 10, so that's 2 times 5. And then what I'm going to do is I can take any things that I have two, since it's a square root, two of the same factor. So I can take out a 2, and then I can also take out a 5. And since that deals with all my numbers, I'm done, and that equals 2 times 5 is 10. So square root of 50, I see as 5 and 10. 5 times 10. I can't do anything else with 5, so I'm going to bring that down. And then 10, as we just said, is 5 times 2. So I have the 5s happening twice. So that's going to be 5. And then I have this 2 that I can't simplify anymore, so it's square root of 2. And really what we're doing, by the way, is we're saying the square root of 5 times 5 times 2. And the square root of 5 times 5 is just going to be 5, if you care why this works. 48. Let's see. I think about 6 times 8. 6 times 8. 6 is 2 times 3. And 8 is 4 times 2, which I'm going to break down to 2 times 2 times 2. The faster you can go, like if you want to go ahead and break this down to 2 times 2 times 2, that's going to save you a lot of work later. So that's just a suggestion. If you can see that and remember that, not a requirement at all. So let me do it the long way though. That would be 8 is 4 times 2. Can't do anything else with the 2. Can't do anything else with the 3. 4, I can break down to 2 times 2. And then I have my last 2. So now this gives me a situation where I have one set of 2's and another set of 2's. So what you do is both of those get brought outside your square root, and then anything left over, which in this case is my 3, is going to stay under the root. Everything in here has to do with multiplying. So 2 times 2 would give me 4 square root of 3. And they have a couple more. So the square root of 24, I see that as 4 times 6. 4 breaks down to 2 times 2. 6 breaks down to 2 times 3. I can take out a pair of 2's, so that would be 2. And then I have 2 times 3 left underneath the radical. So once again, the other way you can think of it is to see that 4 is a perfect square that goes into this. And then the square root of 4 would be 2, and you have 6 left underneath. So when you have tiny numbers, that can be a lot faster. But the bigger they get, the harder it is with multiples. Okay, 60. Let's do 6 and 10. That's probably what most of you will think about. And then I have 2 times 3. Notice I'm not worried about what order I'm putting the numbers or what factors. If I had done 15 and 4 for getting the same thing. And then 2 and 5. I do have a pair of the same factors, which is going to be a 2 outside your square root. And then under the square root, I'm going to have 3 times 5, which would 15. And the last one, 72, I see that as 9 times 8, which would be 3 times 3, and then 8 is 4 times 2. Bring down your 3. 4 breaks down to 2 times 2. I really should have a whole bunch of like little multiplication signs in here, but I usually get a little bit lazy. So I have a pair of 3s. So that's going to come out as a 3. Then I have a pair of 2s. And then I have a 2 left over. And I simplify what's on the outside. So 3 times 2 is 6. Square root of 2. That's it.